Hey guys, this is Miss C here. We are going to go through the Unit 2 test review for your test coming up. And so I'm not going to go through every single problem on this review. I'm going to try my best to put the answers to everything on here. But I'm just going to go through the ones that I think are the most challenging that you might make a common mistake on. And so for number 1, I will tell you guys that the answer to this first one here is once you combine all your like terms and get x by itself, you will get x equals 6. Okay? And so for B here, this is an inequality, and so we're still, for number 1, the directions here say that we are solving for x. We want to get x by itself. And so that's what we're going to do. So the first thing I want to do is add 9 to both sides. And I get negative 6x is greater than or equal to 24. Now this is something we talked about in the past week, is that when we divide by a negative, what happens to the inequality sign? Okay, the inequality sign is going to flip. So instead of greater than or equal to, it's going to be less than or equal to, and your answer is x is less than or equal to negative 4. Okay. C is a little different, but it's really no much harder than what we've done. The only thing going on here is that we have these division bars, right? These fractions. And so the first thing you want to think about is, well, how do I undo division? And that's by multiplication. So I'm going to multiply both sides of the equation here by 7, okay? Because I want to get rid of that 7 in the denominator here. Let's use a different color. So I'm going to get rid of this 7. And when I multiply the left side by 7, I'm just going to put that in the numerator up here. All over 3 equals x plus 3. And now I'm going to do the exact same thing on the other side. I'm going to multiply by 3 and multiply by 3, okay? And then these 3's go away, and I am left with 7 times 2x plus 4 equals 3 times x plus 3. And from here, all you're going to do is distribute the 7 inside and this 3 inside, and then solve for x here as well. So again, I'm not going to go through and finish up this problem, but hopefully that helped you get a start on 1C. And then D is quite simple as well. I'm not going to show you the steps through that one, but you are just getting x by itself here, okay? And the final answer for that one would be x equals negative 2y plus 6, okay? Number 2, so number 2 is talking about systems of equations or systems of inequalities here. I will get you started with 2a with elimination. We are trying to eliminate one of the variables, okay? So if we remember, we want opposite coefficients. So one way to do this is to multiply the bottom equation by negative 2. And so this top equation is going to stay the same as 16x plus 7y equals 5. And this bottom equation is going to become negative 16x plus 6y equals 34, okay? And then when I combine my like terms and add these equations together, I end up with 13y equals 39. Divide by 13, and y equals 3. Well, now we need to plug this in for x, and so you can pick either equation, the top or the bottom, to find your x, and you're going to end up with the ordered pair negative 1, 3. And you can check that in both of your equations for your answer there. Okay, substitution I think was maybe the trickiest one out of the methods we learned this unit. But let's walk through this one. So with substitution, you want one of your variables solved for, which is what we have right here. We have y equal to this statement here, 4x minus 11. So we are going to take what y is equal to and plug it in for y in the other equation, okay? So let's look at that. So we have 3x minus 4x minus 11 equals 10. I just plugged in the second equation into the first equation. Important thing is I need to distribute this subtraction to everything inside. So I'm left with 3x minus 4x plus 11 equals 10. Okay, negative x plus 11 equals 10. Negative x equals negative 1. And then x equals 1. Okay, I like to choose the equation where the y is already solved for. And so then I'm plugging in that x in into that second equation there. And so y equals negative 7. So my ordered pair here is 1, negative 7. Okay? I'm not going to do this graphing problem here. I think you guys are getting a good idea or getting a grasp of graphing. We've done a lot of it this unit. The biggest thing is you want to make sure you look where they intersect. That's how you find your solution here, is you're going to get an ordered pair, and it's wherever the two lines intersect, okay? System of inequalities. Okay, before we can graph these and work with these, we first need to get y by itself. So this top equation here, once you isolate and solve for y, you're going to end up with y is greater than negative 2x plus 3. And this bottom equation here, you do your work, pause the video, and when you come back, you will see that y is going to be greater than or equal to x minus 7. That sign flipped because we divided by negative 1, because we had negative y at the start. Okay, so now that we have our lines, I want to make sure I notice that my blue line is going to be dashed and my orange line is going to be solid. So that's something I want to take into consideration when I'm graphing these. So my blue line I'm going to graph starting at 3, down 2 to the right 1, down 2, right 1, and move my way down. And then I'm going to go up 2 to the left 1, and there is my line. And now I want to think about where am I shading. So this is where I want to choose my test point. And you guys probably remember, I love using 0, 0 because it's so simple. You can choose any point you want as long as it's not on the line, okay? So I'm using my blue equation here, and I have 0 is greater than negative 2 times 0 plus 3. 0 is greater than 3. That is not a true statement. And so this, my test point was 0, 0. And so since that statement is not true, I'm going to shade on the opposite side of the line, right here. Okay? Now let's do our orange line. We're starting down at negative 7, up 1 to the right 1, up 1 to the right, and we're going to keep going that way and the back way. And this one, oh my gosh, guys, I'm just noticing I drew a solid line for my blue line when it should be dashed. Why didn't anyone say anything? Just kidding. So I'm just going to erase this. So this line should be dotted, roughly, okay? And I knew that because it doesn't have a line under its inequality sign, okay? But my orange line should be solid here, okay? And so as I finish drawing that, we have our solid orange line here. And I'm going to use 0, 0 for my test point again. And I'm going to use the original equation. So 0 minus 0 is less than or equal to 7. 0 is less than or equal to 7. Well, that is true. So when I shade, I'm going to shade on the side with 0, 0 there. So I'm going to shade here. And my double shaded part is this top right quadrant. Okay? Hopefully you guys are feeling better about systems of inequalities. There you go for D. Okay. 3, justifying properties of equality, something that we did at the beginning of this unit. So it already gives us the steps worked out. And so what I'm going to do is just look step to step. What am I doing? Well, in step 1 to step 2, it looks like they added 8 to both sides. So I want you to think, what property allows me to add 8 to both sides? Well, that's the addition property of equality, POE, okay? And then in the next step, from step 2 to step 3, it looks like they just combined their like terms. They combined this to get 1/3 x. And so what allows us to group terms together, right? Well, if they're on the same side of the equation, that's the associative property. Okay? And then lastly, what did they do to get from 1/3 x to from 1/3 x just to x? It looks like they multiplied by 3 on both sides to then end up with x equals 6. So that would be the multiplication property of equality. Okay? Great job, guys. Okay, now we got some word problems, okay? So I will work through the majority of these. I might leave a few of these for you to do on your own, but we will do 4, 5, and 6 right here. So I'm going to highlight as I talk, okay? Several students won a raffle and all got the same prizes. There was a stack of hats that the students split evenly, and everybody got 3 t-shirts. If every student won a total of 5 prizes, write an equation that could be used to find out how many hats there were. Okay, every student won a total of 5 prizes. Okay, so it looks like what I'm dealing with is hats and t-shirts. There were a stack of hats that the students split evenly, and everybody got 3 t-shirts. So the goal of this problem is write an equation that could be used to find out how many hats there were. Okay, so I'm going to define my variables. That's the first thing I want to do is I'm going to have x and y. Okay, x is going to be my number of hats. And I think I want to try out y being my number of students. Okay, because it already tells us how many t-shirts everyone got, so putting y as my number of t-shirts doesn't really make sense. Okay, and so let's see if these variables work out with this problem. So several students won a raffle, all got the same prizes. There was a stack of hats that the students split evenly, and everybody got 3 t-shirts. If every student won a total of 5 prizes. Okay. Okay, yes. Okay, sorry guys, taking a second to reread through this. So, the stack of hats, the number of hats were split evenly amongst the students, right? And every student got 5 prizes. And everybody also got 3 t-shirts. Okay, so the total number of hats were split evenly amongst all of the students. And every student got 3 t-shirts. And that's going to equal a total of 5 prizes. This is a tricky problem, to say the least. But this would be the equation you would want to think of. The hats are split evenly. When you think of split evenly, that's division. And everybody got 3 t-shirts. And so this amount would tell me how many hats each person got, plus the 3 t-shirts. This equation tells me what of each variable each person is getting in this situation, okay? All right. Okay, I know that one was a little tricky and we haven't really looked at any like that, but as you can see, I worked through this one with you guys, and you can see that x and y, you can just play around with your variables and work through the problem and think about what do you know, what do you need, what does it tell you? It told me that we had 3 t-shirts, so I knew I didn't need t-shirts as my variable. Okay, so that's number 4. Okay, number 5. A server at a restaurant takes home 68% of their salary after taxes and splits their tips 50-50 with the rest of the staff. that should say they. They took home $1,250 between salaries and tips. Write an equation using X for salary and Y for tips. Oh, so it already tells us our variables that could represent how much money they made last month. Okay, so let's go with these variables here. So we have X is salary and Y is tips. How much money they made last month. So it tells us that they made $1,250 last month. So that's our total here. Okay? They took home, this is X is our salary. They took home 68% of their salary because taxes stink and take your money. And then we have our tips here, and they split their tips 50-50 with the staff. So they only get half of the tips that are really there. Okay? Another way to think of half of the tips is the same as 0.5, right? And so we can write this equation. When we're changing percents to decimals, 68% of X, and we have half of Y. So 68% is written as 0.68X plus half of Y, so plus 0.5Y equals 1250. Okay? 60% of X split their tips, which was Y. Okay, write an equation to represent that's how much money they made last month. So we answered the question correctly. And there you go. Okay? Number 6, Daryl gets paid $50 a week, but also gets paid $40 for every pair of shoes he sells. Write an equation that could represent how much money he makes in a week. So this part right here, this tells me, okay, if he sells one pair of shoes, he makes $40 plus the $50 he already makes. If he sells two pairs of shoes, he gets $80 plus the $50 he spent that week, or he made that week. So Daryl gets paid this $50 no matter what, every week, even if he sells no shoes. But he also gets paid $40 whenever you see this term for every, just every here. I want you to think of slope, because that's exactly what's happening here. If X is our number of shoes, X is your number of shoes, 40X plus 50 tells you how much money that Daryl makes in a week, depending on the number of shoes he sells, okay? All right, let's take a break from word problems for a second. So number 7, is 5, 9 a solution to this inequality? Why not? So let's plug in 5 for X, and we'll plug in 9 for, oh, there's not even a Y here. Okay, so no place to plug in Y. So let's plug that in. So we get 12 minus 4 times 5 is greater than or equal to 24. If there's no place for Y, don't stress about that. Just solve it and see what ends up happening here. Okay, so we get 12 minus 20 is greater than or equal to 24. And this ends up being negative 8 is greater than or equal to 24. No, this is not a solution, because it didn't give us a true statement. Not a true statement, okay? Negative 8 is not greater than 24, so therefore this is not true, okay? Okay, number 8. Brad and Janet are saving money from the prom. Brad's savings can be modeled by this equation. Janet's saving can be modeled by this chart. Okay, so who will have more money saved up at the end of 8 weeks? So first thing, before we can compare who has more money, we need to make these look the same. So I actually am going to change Janet's table and make it into an equation, okay? So I want to see if I can notice a pattern in Janet's table here and see, okay, how much is it from 37 to 68? What's the change going on there? Okay, and so think about that. Do math for a second. You have 68 minus 37, right minus left, and this is 31. I'm going to make sure and see if that's the same change each time, and it is. Okay, so it looks like her common difference, if you will, between each week is $31, right? Well, how much does she start off at with 0 weeks? She starts off with $37, right? And so remember when we talked about arithmetic sequences, guys, we talked about the 0th term. Well, this table kind of gives us a 0th term because we see if this were to be x and this were to be y, we see we have x is 0. So if I wanted to write Janet's equation, this plus 37 at the end would be my y-intercept. That's my 0th term. And then it's changing by 31 each time, which that's my slope. So 31x plus 37. And then we have Brad, which is 25x plus 62. Okay, so now that they look the same, I can now compare them and see who will have more money in 8 weeks. So I'm going to plug in this 8 for x and show my work. And so I have 31 times 8 plus 37, and this is Janet's amount, and so that's going to be 248 plus 37, which is equal to $285. Okay, that's how much Janet saved. And then we have 25 times 8 plus 37. Well, that would be 200 plus, oops, not 37. 62. 200 plus 62, and this would equal $262. So that tells me who saved more money? Janet, because her amount was bigger than Brad's amount. Okay, and then the next question says, who has the greater rate of change? Well, remember, this was the last thing we talked about at the end of this unit. Rate of change is a fancy word for slope. So who has the bigger slope, Janet or Brad? Janet does, because Janet's slope is 31 and Brad's slope is 25. Okay? Okay, a few more word problems here. Catering company charges $30 for setup and then $1.25 for every slider served. Okay, I want to go ahead and first set up an equation for this catering company, okay? So this catering company, remember what I said in the previous word problem about whenever you see every, this is something that you can see, okay, this is going to be my slope. This is my rate of change. And this $30 for setup, that's how much it costs no matter what. And so this equation would be y equals 1.25x plus 30. Okay? That's the first company. The second company charges $25 for setup and then $1.50 for every slider served. So it's the same idea. So we will have y equals 1.50x plus 25. How many sliders do you need to buy for both companies to cost the same? Okay. Both companies to cost the same. So think about what that means, like visually, guys. If they cost the same, that means that's where they intersect. We want the sliders to cost the same amount of money, and so we need to see where these two lines intersect here, okay? Give me 1 second, guys. If we think about what our variables would be in number 9, here, x is the number of sliders, and y is our total amount of money. So I'm sorry for not defining my variables at the start. That was my bad. Okay? And so this is a system of equations here. And we haven't done a problem like this, but this is actually my favorite, where they both are set equal to y. And so what that means is we can just set these equations equal to each other. 1.25x plus 30 equals 1.50x plus 25. And then x is the number of sliders, and that's what we're trying to find here. Okay, so when you solve for x here, you are going to end up with x being 20, and so your answer in context would be 20 sliders. 20 sliders. Okay? Awesome. Okay, next one. Let me make sure I define my variables this time. My bad, guys. You're on a farm that raises cows and chickens, 20 animals total, and the animals have 56 legs. Assume a standard number of legs for the animals. How many cows and how many chickens are there? Okay, let's define our variables. So we have x number of cows, and y is going to be the number of chickens. Okay? And so, oopsie, I know that there's 20 animals in total, and so that means that 20 animals total. The animals have 56 legs in total, too. So now you need to think, okay, 20 animals total, so that means the number of cows plus the number of chickens is going to equal 20, right? And now we have to deal with legs. Okay, well, how many legs does a cow have? 4. So 4x. How many legs does a chicken have? 2. 2y equals 56, okay? And now you're going to solve this system of inequalities here. So cows have 4 legs, and chickens have 2 legs, in case you were wondering or forgot. Okay, and so then once you set up that system, you can solve this using any method you would like. I would recommend elimination here, and you could do -2, and I think you guys can solve this problem from here, so I'm going to leave you to finish that up. Okay, number 11, these are, I know, everyone's favorite problems. This is a literal equation, right? And so it tells you what variable to solve for. So in here we're solving for h. And so to do that, I need to get h by itself. So I'm going to subtract c from both sides. I have r minus c equals fh. Divide by f on both sides. And h equals r minus c over f. Or you could think of it as h equals, if you wrote this, that is totally okay too. Separated it. Okay, let's look at this one. We are solving for L, right? And so the first thing I'm going to do is divide by 2 on both sides. And I am left with P over 2 equals L plus W. I'm going to subtract W. Let's use a different color to subtract W. And I'm left with L equals P over 2 minus W. If you distributed the 2, that's totally okay. No worries in that. You're just going to save your division for the end instead of at the beginning. Okay? Okay, number 12. Here's this function. It can be used to determine how many cookies a chef can bake in an hour. If you were solving for g of x, would it make sense for your answer to have decimals? What about negative numbers? Why or why not? Okay, let's talk about this. So no, it wouldn't make sense for it to have decimals because a chef either makes a cookie or he doesn't. He's not going to make half of a cookie. And he's also not going to make negative cookies either, right? And so if he bakes and time goes up, you're not going to go to -1 hour. You're not going to have a negative cookie. So your values, you can't have, it doesn't make sense. That's your why. I'm not going to spend the time to write all this out, but hopefully you're listening and can write your own answer for this. It doesn't make sense. You either make a whole cookie or you don't. And you can't have negative cookies. Okay? Number 13, characteristics. This is the last thing we talked about this unit, so I'm going to first graph my line starting at -4, and the slope of 2/3 tells me to go up 2 and to the right 3. So So I'm going up 2, right 3, up 2, right 3, up 2, right 3. Down 2 to the left 3, down 2, left 3, down 2, left 3. And I'm going to connect my dots here. And here we go. So domain. Remember we talked about this, guys. The domain for a linear function, as long as there is a slope, the domain is going to be negative infinity to infinity. The question you can ask yourself is, is there anything horizontally stopping this line from going any further, right? And there's not. And so this domain is going to go on in both directions forever. The next thing to think of is it increasing. Well, if we start at the left and I drag my pencil, my line is going up. So that means it's increasing, and it's increasing forever. It's never going to change direction. So increasing is negative infinity to infinity as well. The next thing we're looking for is our x-intercept. And so our x-intercept is where it crosses the x-axis. And so that would be right here at 6. And we write intercepts as points. And so it would be 6, 0. And my y-intercept is down here. And it's also my constant at the end of this function. And so I would write this as 0, -4. Okay? Last thing is end behavior. And so I'm going to take my highlighter, and the first thing I can fill in is as x goes to negative infinity and as x goes to infinity. That's always going to be the same. And then I'm thinking, what is y doing? So if I am moving along this line, where is my line going, my yellow line? It's going up, right? And so that means as x goes to infinity, y goes to infinity, because as x goes to the positive numbers, as x goes to infinity, y also goes to infinity. Let's look at the other way. As x goes to negative infinity, my line goes down. My yellow line is going down. And so then I would say as x goes to the left, as x goes to negative infinity, my y also goes to negative infinity. Okay? Okay, I know this is a long review. Hopefully this is helpful, though, for you guys to work through. So the next thing is arithmetic sequences, okay? Find a sub n for the arithmetic sequence. So we are just writing an explicit equation. So if we remember, a sub n equals a sub 1 plus d times n minus 1, okay? So the things I need to find are my first term here, and which is my first term, and my common difference. So my first term is 7, so I'll go ahead and write that. A sub 1 is 7, and now I need to find d. And so remember, we want to take our term at the right and subtract the term that comes before it. So 3 minus 7 is -4. Okay, let's do the next one. -1 minus 3 is also -4. Okay, so that tells me that d is -4. Now I can finish up this equation here. And so I have a sub n equals 7 minus 4 times n minus 1. I need to make sure to distribute. Sorry guys. Distribute this -4 inside the parentheses, and I get a sub n equals 7 minus 4n plus 4, and this equals, simplified entirely, -4n plus 11. Done a lot of practice with this, so hopefully you feel good about writing the explicit form. If you wanted to write the recursive form of this equation, I'll do that really quick for you guys. Recursive would be a sub n equals a sub n minus 1 plus d, semicolon, when a sub 1 equals blank. So I would write this as a sub n equals a sub n minus 1 minus 4, semicolon, a sub 1 equals 7. Okay? Take a stab at 15 on your own. Honestly, if you want to try all of these, pause the video and come back. That would be awesome. So number 15, what is the 10th term? 10th term in the arithmetic sequence, whose third term is 17 and whose common difference is 8. Okay, this is a great question. So what it gave us, this 10 here, is my n. Whenever it asks you for the term number, or find the term, n is equal to that value there, so n equals 10. Okay, it gave us the third term. It gave us the common difference. This is helpful, d equals 8, but we really need the first term, right? And so if we're at the third term, 17, I need to find the first term. So I have the second term here and the first term here. Well, if I were to find my my next terms, right, I could just add 10 and go 27, 37. Add 10, add 10. Oh, not 10. Sorry, guys. 8. My common difference is 8. So I'm adding 8, adding 8. So that would be 25 and then 33, right? Honestly, you could keep counting up to the 10th term since we're already at the 5th. But I want to show you guys the other way to do this as well. And so I'm going to work backwards to the first term. And so that means I need to subtract 8 to find the term here is 9 and subtract 8 again to get 1. Because think about it. If I add 8, I would get 9. Add 8 again to get 17. So that means my first term is 1. Okay? And so now I can really work with this problem. A sub 1 is 1. And so if I'm trying to find a sub 10 equals 1 plus 8 times 10 minus 1, because 10 is n. Everywhere I see an n in the equation, I am plugging in 10. So when I solve this, I get a sub 10 equals 1 plus 8 times 9. A sub 10 equals 73. Okay? Number 16, convert between recursive and explicit. Okay, so this one gives us the explicit formula, right? So first thing off the bat is that remember where your common difference is. This is your common difference. So d equals 7. Now I need to find a sub 1. So I'm going to plug in 1 for n and find my a sub 1. A sub 1 is 7 minus 11. A sub 1 equals negative 4. Okay? I'm going to change the color there. A sub 1 equals negative 4. And now I can convert and write this in recursive form. So recursive, remember, I'll write it here. You guys are going to get this on the test as a formula. Okay, and so a sub n equals a sub n minus 1 plus 7 when a sub 1 is negative 4. That's it. Okay? Now this one gives it to us in recursive form, so I want to identify what I know. Negative 4 is my d, and a sub 1 is 6. Right? So now I just want to plug this into the explicit form here. So explicit form is a sub n equals a sub 1 plus d times n minus 1, and I'm plugging in a sub 1 and d. So I have a sub n equals 6 minus 4 times n minus 1. So simplified completely would be a sub n equals negative 4n plus 10. Okay? This one gives us two functions, and it says, what is the solution to f of x equals g of x? This is a good question. So all it's asking us to do is set f of x equal to g of x. So I'm going to do 4x plus 19 is equal to 6x plus 35. And I want to solve for x. If it's asking for a solution, solve for something. Solution, solve. So when I simplify and get everything on the right side, I'm going to end up with negative 2x equals 16. And then x equals negative 8. Okay? Write a function, last two problems here. Write a function that represents the data in the table. Okay, so we have this table here, and I need to write a function, right? And so remember, we can think of a function as we've learned a function is y equals mx plus b, right? Where m is the slope and b is the y-intercept, right? And we've also learned about arithmetic sequences, right? Where you can think of a sub n equals d times n plus a sub 0, right? Where these are the exact same thing. B and a sub 0 are the same thing. Your slope and your common difference are the exact same thing. And so let's see if we can, what's our common difference between these? Well, here we're going up by 7, right? We're adding 7 each time. Our x's are also going up by 2. We have to be careful because it's not just going up by 1, right? And so you could think about rate of change, but also we need a sub 0. This is second term, fourth term, sixth term, but we need to go backwards to 0, right? And so if I wanted to do that, to go back to 0, I would need to subtract 2 from x, so that means I would also need to subtract 7 from this term right here, and that would give me 4. So my 0th term is 4, okay? Work backwards if you can to find where x is 0. The next thing we need to find is our slope. Remember, guys, slope, we learned rate of change. So there's a few ways to do this problem. I'm going to choose to use rate of change for this. And so I'm going to choose one point here and another point here. I'm just going to choose these 2 points. So this point is 8, 32, and this point is 6, 25. And I'm going to use my slope formula. So I have y2 minus y1 over x2 minus x1. I'm plugging in my y's into the top. So I have 32 minus 25, and then I'm plugging in my x's. 8 minus 6, and then I end up with 7 over 2. So there's my slope. There's my y-intercept. Let's write this function. We have y equals 7 over 2x plus 4. There you go, guys. Okay, last problem, and then we are done, guys. Number 19, error analysis. What mistake did the student make in their work? Show the correct steps the student should have taken at the end and end up with the correct solution. Okay, so it looks like they started with an equation. Oh, and then it looks like they added 11 to both sides. What should they have done in this problem? They should have subtracted 11 from both sides, because if they added 11, they're not going to cancel out these terms right here. And so that's the mistake they made. Added 11 instead of subtracted 11. Instead of subtracting. So let's do the correct steps. So if we start with 2x plus 11 equals 31, if we subtract 11, we end up with 2x equals 20. Divide by 2, x equals 10. Okay? You can see how one mistake can totally mess up your whole answer there. So guys, I hope this video is helpful for you studying for your test coming up. Happy studying, and we'll see you guys